All right, going to do some problems pre-calculus style in section 3.3 using the properties of logarithms. The properties are the change of base rule, which says if you got a logarithm base b of some number a, that you can change that to log of a over log of b with any base that you want. Got to be the same thing, but it can be anything. Got to be a positive number, but can be anything. The ones that we're going to use most often will be log base 10, because that's the common log. That's what, when you hit the log button on your calculator, that's log base 10, and natural log, which is log base e. So if we're going to change it to something, we're going to change it to one of those two, because that's doable with our calculators. That's one of the rules, or one of the properties. And then the other ones, we have a property that says if you have the log, doesn't matter what the base is, of a times b, that's equal to log a plus log b. That multiplication splits up into addition. This is just a quick review of things you have in your notes. And then if if multiplication turns into addition, then of course, you guessed it. You didn't have to guess, you already seen it in your notes. And that means also, if you apply this rule lots of times, that if you have log of something to a power, that can come to the outside. Right, so that's just a reminder of the rules, the properties that we're going to be using. For numbers 5 through 11, we're using the change of base rule to rewrite log base 5 of x as log base 10 of x, log base 5 of x, log base 10 of 5, that's what I meant, changing it to base 10, or you can do natural log. I'm going to stop writing log base 10 now, because when I just write log with no number there, that means log base 10. That's universal. So log base 1/5 of x turns into log of x over log of 1/5, or natural log of x over natural log 1/5. Number 9, log base a of 3/10 turns into log of 3/10 over log of a, or natural log of 3/10 over natural log of a. And number 11, the log base 2.6 of x can turn into log x over log 2.6, or natural log x, natural log 2.6. And any of those could change into, you could change it to any base you want. It's just that 10 and natural log, again, those are the ones that we have in our calculator. So that's what we use. That's what we like to change it to. I'll be right back. I'm going to shut my door. Hang tight. All right, I'm back. Where did we leave off? We just did numbers, let's see, 5 through 11. And now we're going to do 13 through 19 with calculator. We're going to use the change of base formula to evaluate these. So you got a choice here. You can either make this, just like we did in the last 4 problems, you can make that log 7 over log 3, or you can make it natural log 7 over natural log 3. And I'm just going to show you, in case you think this is some kind of crazy math magic or something, that those give you, I guess it is magic, sort of, that these indeed give you the same thing. There's using log, and here's using natural log 7 over natural log 3. How about that? So I'm a big fan of the old natural log function because I'm a calculus teacher. So I'm going to use that one for the rest of these. So that means that log base 1/2 of 4 is the same as natural log 4 over natural log 1/2. Natural log 4 over natural log 1/2. If you do not close that parentheses right there, you are going to get the wrong answer. And it would be your fault, not the calculator's fault. So don't be doing that. Log base 6 of 0.9 is the same as natural log 0.9 over natural log 6. Natural log 0.9 over natural log 6. Book's asking for 3 decimal places. I still have my calculator set up to do that. That's natural log 1460 over natural log 15. Natural log 1460 over natural log 15. All right. In the next couple of problems, going to retire my calculator for a little bit. Actually, I think for the rest of this assignment, right? Yeah. Going to do 21 through 24. And we're trying to use the properties to rewrite these expressions with just natural log 4 and 5. So 20 is 4 times 5. And then using that multiplication to addition property, that's what we're looking for. Number 22, at the natural log of 500. So probably need to factor that. 500 is 5 times 100, but 100 is 25 times 4. So that's 5 times 25 times 4, all factored out. So that's natural log of 5 cubed, and then the multiplication to addition lets me do that. And then finally, the power can come to the outside. I'll tell you what, in calculus class, like in actual, not pre-calculus, but calculus class, this is probably the logarithm rule that we use the most, the one that says that that exponent can come to the front. All right, natural log of 25 over 4. So I want to factor that all into 5s and 4s. So natural log of 5 squared over 4. Division turns into subtraction, and then that exponent can come to the front. That's how we roll through that. And the last one of these, natural log of 5 over 2. So that's a little tricky there to figure out how you're going to do that, I guess. So that's natural log of 5 minus the natural log of 2. At 2 is equal to (4 to the 1/2), right? Because the 1/2 power means square root, and then you could do that. So that was a little tricky to see how you can get that 2 in terms of the 4, but that's how you do that. All right. What's next? 37. We are going to use the properties of logarithms to rewrite and simplify the logarithmic expression. Okay, so let's see what we think that means. Log base 4 of 8. So 8 is equal to 2. Well, let's see. I guess what they're looking for is how do you turn 8 into 4 using exponents? Well, the cube root of 8 is 2, right? 8 to the 1/3 is 2. So that means that 8 to the 2/3 is equal to 4. And likewise, 4, if you take the square root of 4, that's 2, and if you cube that, you get 8. So I think that's probably the key here. If we then do log base 4, rewrite the 8 as 4 to the 3/2, and then recognize that, like in the last section, log base 4 of 4 to the something, it's just these. It's just this, right? That's like asking, what do you have to raise 4 to get 4 to the 3/2? Oh, the 3/2. 37 to 43 odd. 39 log base 2 of 4 squared. Is that 3 to the 4th supposed to be inside or outside? I guess it's supposed to be outside. I'll check in the back of the book to see. I'm reading this that they mean like that, and then that times 3 to the 4th. I think that that's what they mean. Not sure, but we'll check. So this 4 squared is 16. That's the same as 2 to the 4th power. Not because I can switch those, that's not a rule, but because 4 squared is 16, and 16 is 2 to the 4th power. So that's the same as log base 2 of 2 to the 4th times 3 to the 4th. This is 4, because what do you have to raise 2 to get 2 to the 4th? 4. So I think that that's the answer. Let me just check in the back of the book and see if I'm interpreting the problem right. Chapter 3, almost there. 3.3. Number 39. No. The whole thing was supposed to be inside, so this is all supposed to be inside that logarithm. So we're supposed to do that as log base 2 of 4 squared. That is 4. And then that would be plus log base 2 of 3 to the 4th. And then I could bring that 4 to the outside. So they have it as 4 plus, then they're using 4 times log base 2 of 3. So that was all supposed to be inside. That's their bad for not putting parentheses around that, I think. Number 41, natural log of 5e to the 6th. That's 5 times e to the 6th. So that's subject to that product turns into sum rule. And then this can come out to the front. And then the natural log e, a natural log of e is 1. That's like saying, what do you have to raise e to get e? Oops, that's supposed to be plus. All right. Number 43, got natural log of 6 over e squared. So that's subject to this rule. And then it's kind of logarithm identity. Natural log of e to the something, we just get that. So that's natural log of 6 minus 2. What do you have to raise e to get e squared? 2. Let's see, number 47. Use the properties of logarithms to expand as some difference constant multiple of logarithms. Okay. So same kind of thing we're doing here. Log base 10 of 5 times x is log base 10 of 5 plus log base 10 of x, because multiplication turns into addition of logs. 49, log base 10 of t over 8 is equal to log base 10 of t minus log base 10 of 8. 51, log base 8 of x to the 4th, exponent can come to the front, is 4 times log base 8 of x. Number 53, the natural log of, I'm just going to go ahead and write that the square root of z is the same as z to the 1/2, and that 1/2 can then come to the front. Sure is important to understand how roots and rational exponents go back and forth. 55, natural log of xyz is the natural log of x plus the natural log of y plus the natural log of z, because multiplication turns into addition with logarithms. Shuffle my papers around for a second. And continue with number 57. The log base 6 of ab cubed c squared is equal to log base 6 of a plus log base 6 of b cubed, but the cubed can go out to the front, plus log base 6 of c squared, but the 2 can come out to the front here. 59. You got to know that the cube root of something is the same as the 1/3 power. Just got to know that. 1/3 natural log of x minus natural log of y. I need these brackets, they could be parentheses, that doesn't matter. That needs to be, that's like of the whole thing, right? So you either need to have the 1/3 and then that whole thing in parentheses, or you could have another 1/3 here, like distributed. One or the other. 61. We have natural log of x squared minus 1 over x cubed. And they say it for x greater than 1. They just have to say that because this has to be, you can't take logarithms of negative numbers, so that doesn't change anything about what we're going to do. There's nothing you can do with this. Don't make the mistake. This is subtraction inside a logarithm. There's no rule for what to do with this. Our rule is if there's multiplication or division inside a logarithm, that can change. But this cannot. This can, though. That's natural log x squared minus 1, 3 natural log x. That can come to the outside. This cannot because of the minus 1 in there. You can't peel it off when there's something else going on inside. 63. Got natural log x to the 4th square root of y. I'm going to write that as y to the 1/2 because because it's better. So going to split that up. I got natural log of x to the fourth, but I'm going to bring that to the front, plus, because multiplication turns into addition, plus the natural log of y to the 1/2, but I'm going to bring the 1/2 to the front because that's one of the rules, minus, I've got division here, so minus z to the 5th, but the 5 can come to the front. With a little bit of practice, you can do that all in one step. It ain't that hard. I think that I'm going to pause this video here and put the rest of the problems in the second video, part 2. Thanks.